This is the first part of section 6.3, dividing polynomials. In this part of the section, I'm going to show you how to divide polynomials using long division. And in the second part, I will be showing you how to divide them using synthetic division. So let's get started with long division. And to do that, I want to start with remembering how we did long division in elementary school, right? We did it the long way where we wrote everything out. And so we start with, we're going to divide by 12, and I make my little division box, and I want to divide 276 by 12. Okay, if I'm going to divide 276 by 12, one of the things I do is, instead of trying to figure out the whole part at once, I actually try to figure out what can I divide. How many times does 12 go into just the first two numbers, 27? So in this case, right, 12 goes into 27 twice, right? So 2 times. Then if you remember the long way of dividing here, we take 2 times 12, right? 2 times 12, and we get 24. And what I do with that 24 is I subtract it, and 27 minus 24 is a 3, and then I bring down my 6, and I get 36. So the next time I ask, how many times does 12 go into 36 now? Well, in this case, 12 goes into 36 3 times. 3 times 12 is 36. I subtract that, and I end up with 0. So 12 goes evenly into 276. It goes in there 23 times. Now, we also had problems like this one, 395 divided by 7. And when we were first learning to do long division, set up our problem, and again, we would look at this and say, okay, 7 doesn't go into 3, so 7 goes into 39, and 7 goes into 39, it's going to be 5 times. 5 times 7, 35. Do my subtraction. That leaves me with 4. Oops, got an extra line there. Sorry about that. Okay, so then bring down my 5, I get 45. 7 then is going to go into 45 6 times. Okay, well, the problem with 7 goes into 45 6 times is that in this case, that's only 42. Okay, so when early on when we learned our long division, what we would do if that 3, because I'm out of numbers here, is we called that a remainder. So we would write something like 56 remainder 3. So what we're going to do today with polynomials is similar to what you did back in elementary school with long division. We're going to be dividing. There may possibly be some remainders, and we're going to find out how to actually divide a polynomial by another polynomial. Okay, so let's look at how that would happen. We're going to set up our problem the same way we set up a normal division problem. What I'm dividing by, which in this case happens to be x minus 3, is going to go into x squared plus 3x minus 18. So I'll set up my little division symbols here. So I'm dividing by x minus 3. That's going to go on the outside. And on the inside, we'll go x squared plus 3x minus 18. Now you do want to make sure that when you're writing this out, if your polynomial here is missing any of its terms, you would fill in a placeholder of a 0 for that particular term. This one has all its terms because it's got x squared and then x and then a constant, so there aren't any missing. So here's what I'm going to do. Kind of like I do with my other long division, I'm not going to worry about the whole thing at one time. What I'm going to look at is I'm going to worry about making my x, the first part of my binomial here, and I'm going to try to see how I would make that into x squared. That's the only part I'm going to concentrate on. Whatever happens with the latter part of my polynomial, the minus 3 part and the 3x part, we'll just kind of deal with that as it goes. So to make x into x squared, I would need to multiply by x, right? X times x is x squared. So up here I'll put x. And then just like on regular long division, I'm going to take x and I multiply it times x minus 3. So if I do that, I get x squared minus 3x. Okay, and if you remember, what we had to do in our long division is then we subtracted this to see what was left. So I'm going to do the same thing. When I subtract, x squared minus x squared gives me 0. 3x minus negative 3x is actually going to be 3x plus 3x, so that's going to give me 6x. Okay, and then just like in my regular long division, I bring down the next term that I have, so this is going to be minus 18. And now I'm trying to work with this x and this 6x. So again, what do I multiply times x? That's going to make that into a 6x. So up here, that's a positive 6. So I'll multiply 6 times x minus 3, makes 6x minus 18. And when I subtract that, 6x minus 6x is 0, and negative 18 minus negative 18 is also 0. So this particular polynomial divides evenly. So in other words, just like any other multiplication or division problem, x plus 6 times x minus 3 would equal x squared plus 3x minus 18. Okay, let's try one more example. And in this last example, you'll notice that I'm missing some terms. So let's see how we would deal with that. Okay, so again, I'm dividing by x plus 3, so I'll put that on the outside of my division box here. Now inside, I start with x cubed, but I'm missing a couple of terms. I'm missing the x squared terms, so I'll just fill in a 0x squared. And I'm also missing the x term, so I'll fill in a 0x. But I do still have my constant, so plus 27. So I want to go ahead and fill in all those missing terms. Now again, I'm going to concentrate on how do I get x to make just my first term. If, the plus 3 part works out, great. If not, we'll deal with the remainder. So x into an x cubed means I need an x squared. So I'm going to multiply those out. X squared times x plus 3, and I get x cubed plus 3x squared. And then I'm going to subtract that. So x cubed minus x cubed is 0. And this is where you see I filled in my placeholder. This is why. 0x squared minus 3x squared gives me a negative 3x squared. Bring down your next term, right? Your 0x. And then again, we're trying to make x into a negative 3x squared. So that's going to take a negative 3x to make that happen. So negative 3x times x gives me a negative 3x squared. And negative 3x times 3 gives me a negative 9x. So I subtract, and I get negative 3x minus negative 3x squared. 0x minus negative 9x is actually going to be a plus 9x. Okay, bring down my 27. And then I need to figure out x. I want to make that into a 9x. So I would probably multiply it by a positive 9. And when I multiply by 9, I get 9x plus 27. I subtract, and I end up with 0. If you end up with a remainder, we'll do just like we did in elementary school. We would go back up to the top here with our answer, x squared minus 3x plus 9. And for now, we're just simply going to write r for remainder, and we're going to tell what the remainder was. If the remainder was 3 or if the remainder was 5, we'll just simply write r3 or r5. Okay, we'll talk about what else you could do with that remainder at some point, but for right now I just want you to put r for remainder and whatever that value would be.